In the final years of World War II, deep inside a dimly lit hangar on the outskirts of Berlin, a group of German engineers stood frozen in silence. Before them sat a battered American warplane, the Republic P-47 Thunderbolt, its fuselage riddled with bullet holes but its heart still intact as a 2,000 horsepower Pratt Whitney R-2800 engine. It was a monster, a machine that had carried countless American pilots through storms of flak and fire. The Germans had captured it intact, and now, for the first time, they could peer into the beating heart of American air power. They expected to find familiar mechanics, something they could replicate. Instead, what they uncovered left them stunned. The sheer complexity, the precision machining, the advanced metallurgy, it was beyond their reach. In that moment, one of the Luftwaffe's top engineers reportedly whispered, This is from another world. What the Germans discovered inside that engine revealed more than technical brilliance. It revealed why the Allies ruled the skies. This wasn't just about horsepower, it was about industrial might, ingenuity, and a nation's ability to build faster, stronger, and in greater numbers than anyone else. It began with smoke trailing across the cold skies of occupied France. A Republic P-47 Thunderbolt, call sign Lucky 7, limped home from a bombing run over the Ruhr. Its massive radial engine had taken hits from 20 numb cannon shells, but the pilot fought to keep it in the air. The P-47 was famous for its resilience. It could take punishment that would shred most aircraft. Yet this time luck ran out. The aircraft sputtered, lost altitude, and landed in a patch of farmland east of Lille. German patrols reached the wreck within the hour. What they found was unlike anything they had seen before. The plane's sheer size, its armored cockpit, massive fuselage, and thick wings, spoke of an engineering philosophy alien to the Luftwaffe's sleek, light designs. When word reached Berlin that an intact Thunderbolt had been captured, orders came swiftly recover it, transport it, and preserve the engine at all costs. Weeks later, a convoy of trucks arrived at a secure Luftwaffe testing facility. Inside a sealed hangar, the P-47's remains were carefully unloaded. The Germans had analyzed captured Spitfires, Mustangs, and Lightnings before, but this was different. The Thunderbolt was feared and respected by Luftwaffe pilots. They called it the Jug, a brute that could dive like a stone, outclimb Messerschmitts, and shrug off hits that should have torn it apart. For German engineers, this was more than curiosity, it was desperation. By 1944, the Reich was bleeding fuel, aluminum, and hope. The Allied bombing campaign was erasing factories faster than they could be rebuilt. Yet here, perhaps, was a key to understanding why the Americans seemed to field machines that refused to die. As the hangar doors closed, floodlights illuminated the mangled but magnificent shape of the P-47. Engineers from Junkers, Daimler, Benz, and BMW gathered around the radial engine, a Pratt Whitney R-2800 double wasp, 2,000 horsepower of raw defiance. The moment the cowling was removed, the room fell into reverent silence. The R-2800 wasn't just powerful, it was overbuilt, almost absurdly so. Where German engines like the Daimler, Benz DB605 were liquid-cooled, elegant, and finely tuned for speed, this American beast was air-cooled, rugged, and built to take damage. The Germans had obsessed over precision, the Americans had mastered endurance. One engineer ran his hand along the engine's cooling fins, whispering that he had never seen metalwork like this. Another examined the supercharger assembly, and muttered that it was decades ahead of anything they could produce under war conditions. They took measurements, sketched every valve, every bolt, every fin. Yet with every diagram, one truth became clearer. The Germans couldn't build it. They lacked the alloys, the machining tolerance, and the industrial capacity to replicate what the United States was producing by the thousands. For the Luftwaffe's technical command, the discovery was both awe-inspiring and devastating. This wasn't just an engine. It was a statement of industrial might. The R-2800 embodied the difference between a nation fighting for survival and one fighting with endless resources. America's factories, untouched by bombs, churned out power plants that could outlast the war itself. As the engineers concluded their examination, one senior officer reportedly said, "If we had engines like this, the war would be different." His words hung heavy in the air. Because they all knew. They never would. The Germans could copy the design on paper, but not the production methods that made it possible. In the months that followed, fragments of that engine were sent to research centers, but nothing came of it. The R-2800 remained a marvel they could not match. The captured Thunderbolt, once an enemy machine, became a silent teacher. Proof that in modern war, power wasn't just built in laboratories or on drawing boards. It was forged in factories, by the sheer will of a nation that had mastered the art of making the impossible routine. When the R-2800 engine finally reached the Luftwaffe's experimental division at Rechlin Air Base, the most secretive engineers of the Third Reich gathered around it with quiet intensity. These were not ordinary mechanics. They were the best minds in German aviation, men who had built the engines that powered the Bf-109, the F-190 and even the jet-propelled Me-262. Yet as they approached the American machine, they sensed they were about to confront something entirely different. The P-47's Pratt and Whitney double-wasp engine, though damaged from its crash, still radiated a kind of brute strength. Its thick, cylindrical structure looked more like a locomotive than an aircraft power plant. 2 rows of 9 cylinders each, 18 in total, stood like a wall of steel muscle. Its complex network of pipes, turbochargers, and intercoolers was alien compared to the streamlined, liquid-cooled systems the Germans favored. Technicians began disassembly under the supervision of Oberingenieur Karl-Heinz Osterreich, one of the Luftwaffe's most respected engine analysts. They expected to find rough manufacturing. After all, the Germans prided themselves on precision, while American machines were often mocked as crude but numerous. But as soon as they loosened the bolts and removed the casing, the myth fell apart. Inside the R-2800 lay a masterpiece of symmetry and resilience. Each cylinder bore evidence of machining tolerances so tight that even German micrometers strained to detect imperfections. The metallurgy astonished them. The alloys used for the pistons and exhaust valves had higher heat resistance than anything in the Reich's inventory. Osterreich ordered the parts to be cleaned, catalogued, and analyzed down to the smallest bolt. When the inner components were exposed, a hush fell over the room. The Germans were staring at engineering that felt, in their words, industrial but divine. The precision was not achieved by the hands of craftsmen. It was born of machines. Machines that could reproduce this level of complexity by the tens of thousands. This was the key revelation. The Germans realized the Americans had achieved something revolutionary. Not just power, but mass production precision. Every double-wasp engine rolling off an assembly line in Connecticut or Michigan was nearly identical, performing at peak efficiency without the need for the master craftsmen the Germans depended on. While German factories required weeks to fit each Daimler, Benz or Junkers engine, the Americans had automated excellence. The deeper they went, the more unsettling it became. The turbo supercharger system, built by General Electric, was a marvel all its own. Using exhaust gases to drive a turbine that compressed incoming air, it allowed the Thunderbolt to perform at full power at altitudes above 30,000 feet, altitudes where Luftwaffe fighters gasped for oxygen. The Germans had tried to perfect similar systems, but their engines often overheated or exploded under stress. The Americans had solved it with elegant simplicity, heat-resistant alloys, flawless balancing, and sheer reliability. After weeks of analysis, Osterreich compiled his report. It was both an acknowledgement and an obituary. He wrote that the R-2800 represented a level of industrial mastery beyond the capacity of the Reich under present conditions. He noted that even if they could replicate the design, they lacked the resources, the raw materials, the manufacturing consistency, the time, to reproduce it in any meaningful quantity. When the report reached the Luftwaffe's command, the reaction was mixed. Some dismissed it as defeatist, others understood its terrifying truth. The Americans weren't just building engines. They were building an empire of production. Every captured Thunderbolt that fell from the sky was easily replaced, its engine forged in another untouched factory across the Atlantic. And so, the Germans finished their dissection in quiet resignation. The R-2800 wasn't merely a technological artifact. It was a mirror reflecting their own decline. In its pistons and turbines lay the undeniable proof that industrial warfare had evolved beyond the reach of even Germany's most brilliant engineers. When the German engineers began analyzing the Thunderbolt's engine metallurgy, they expected something familiar, perhaps a variation of the alloys they already used in the Daimler, Benz or Junkers engines. Instead, what they found made their stomachs tighten. The metal composition of the R-2800 was, in many ways, alien to them. Under the flickering lights of the Rechlin test hangar, samples were sent to the Luftwaffe's materials laboratory for chemical analysis. The results, when returned, were quietly devastating. The Americans were using high-temperature alloys containing elements like nickel, cobalt, and chromium in quantities that the German war economy simply could not afford. Each piston crown, each exhaust, and even the cylinder heads had been crafted from heat-resistant materials that could survive brutal thermal stress, something the Luftwaffe's engines continually struggled with during high-altitude operations. The Pratt Whitney R-2800 wasn't just powerful, it was durable. It could run at high boost pressure for hours, withstand flak damage cooling fins, and still deliver its full 2,000 horsepower. The Germans, meanwhile, were pushing their liquid-cooled Daimler, Benz and Junkers Jumo engines to the breaking point. Pilots often reported their engines seizing, catching fire, or suffering catastrophic failure after only minutes of combat at full power. The German engineers soon realized the root of the problem wasn't design. It was material science. Germany was starved of rare elements. Allied naval blockades had choked off access to vital imports, and synthetic substitutes simply couldn't match the performance of American alloys. The Americans, with access to endless supplies of nickel from Canada, chromium from Africa, and molybdenum from South America, could afford to make every component from the best materials on Earth. The Reich could not. As one engineer noted in his report, "We have the mind, but not the metal." That single sentence summed up the Luftwaffe's predicament. They could understand the Thunderbolt's engineering brilliance in theory, but they couldn't reproduce it in practice. The cooling system revealed an even deeper contrast in philosophy. The P-47's massive air-cooled radial engine, coupled with its turbo, supercharger and oil coolers, could absorb punishment no liquid-cooled design could match. While the Germans relied on delicate radiators and coolant systems vulnerable to even a single bullet, the Thunderbolt needed none of that. It was self-contained. Its cooling achieved through airflow, its reliability through redundancy. Even with multiple cylinders damaged, it could still bring a pilot home. One Luftwaffe technical officer, stunned after reviewing the test data, wrote that the R-2800 embodied the brute philosophy of American warfare: quantity, quality, and survivability in one package. It wasn't elegant like a Daimler-Benz DB605, but it didn't need to be. It was made to last. The discovery carried grim implications for Germany's war effort. By 1944, the Luftwaffe had lost control of the skies over Europe. Every day, swarms of P-47s and P-51s escorted bombers deep into German territory, while the Luftwaffe's depleted fighter units struggled to keep engines running long enough to intercept them. The engineers at Rechlin now understood why. The Americans had industrial and metallurgical superiority that no tactical innovation could offset. When the engineers presented their findings to Luftwaffe command, silence filled the room. They were no longer just fighting aircraft. They were fighting a system of production so vast that it could afford to build perfection by the millions. The Thunderbolt's 2,000 horsepower heart was proof of that. In the end, the Germans could only marvel. They took samples, drew diagrams, and ran tests, but none of it could close the gap. The R-2800 was not just an engine. It was the physical embodiment of a nation's limitless industrial will, a mechanical symbol of why the tide of war had irreversibly turned against them. Once the engineers at Rechlin finished their dissection of the P-47's power plant, the Luftwaffe's high command issued an order that reflected both desperation and ambition: attempt to reverse engineer the R-2800 double wasp. It was a bold directive, one that spoke to the Reich's hope that somewhere, hidden within that engine's design, lay a key that could level the skies again. Blueprint teams from Junkers and BMW were summoned. They began drafting sketches, creating exploded diagrams of every mechanical section: the twin-row cylinders, the intricate turbo supercharger, and the unique baffled cooling system. The aim was not simply to copy the American engine, but to adapt it into something that could be built with German materials and methods. But as soon as work began, the enormity of the task became clear. The first challenge was the turbo supercharger. General Electric's design for the P-47 used precision, balanced turbines capable of operating at extreme temperatures. The Germans had attempted similar systems for their high-altitude fighters and bombers, the BMW-81 and Junkers Jumo 2033. But theirs were plagued by constant overheating, bearing failures, and energy losses. Every attempt to reproduce the American system failed. The metallurgy, the balancing precision, and the turbine geometry were all beyond what Germany's overstressed war industries could deliver by 1944. Then came the cooling problem. The Americans' air-cooled approach seemed crude to German engineers, accustomed to liquid-cooled efficiency, yet it worked flawlessly. The R-2800 could absorb punishment from gunfire or flak without leaking coolant, a fatal weakness for the Luftwaffe's liquid-cooled fighters like the Bf-109 and F-019UD. German test pilots had long complained that a single bullet through the radiator meant instant death. The Thunderbolt's radial engine, by contrast, shrugged off hits like a steel hammer. Recreating that resilience required not just design changes, but an entirely different philosophy, one that prized endurance over elegance, survivability over speed. The engineers attempted to build a scaled prototype, substituting rare nickel alloys with steel mixtures and low chromium substitutes. The test run was catastrophic. The engine reached 200 horsepower before the pistons began to seize and the bearings melted from heat distortion. The project director reportedly slammed his clipboard onto the bench and declared, "We are trying to carve granite with a chisel of wood." Meanwhile, as German scientists toiled in their underground workshops, Allied bombers filled the skies overhead. Rechelen itself was struck multiple times by British night raids. Every setback reminded the engineers of the futility of their effort. The Americans could build hundreds of R-2800s, while Germany could barely sustain fuel production for the next month's sorties. Still, the engineers persisted. Pride demanded it. They believed that if they could at least understand the R-2800 fully, the knowledge might inform post-war aviation. But even as they studied, they could not ignore the symbolism. The P-47 engine was more than a piece of machinery. It was a testament to America's industrial power, the embodiment of a system that could innovate and mass-produce with unstoppable rhythm. When the last report was compiled, it was damning in its honesty. The engineers concluded that while Germany could design faster engines on paper, they could not sustain them in reality. Their precision-made machines required constant maintenance, perfect fuel, and gentle handling. The R-2800 by contrast thrived on chaos. It could run on low-grade fuel, withstand poor conditions, and still perform flawlessly. It was the engine of an industrial civilization built for total war. By the time the report reached the Luftwaffe's high command, it was too late. The Allies had achieved air supremacy. Germany's dream of matching the Thunderbolt's heart had become a metaphor for its entire war, brilliant in conception, doomed in execution, and ultimately crushed beneath the weight of an enemy that could outproduce and outlast anything they could build. When the analysis of the R-2800 engine reached the Luftwaffe's upper command, it was more than an engineering report. It was a wake-up call. The findings spread through the corridors of the Air Ministry like a dark whisper. America's power lay not in its pilots, but in its factories. General der Jagdflieger Adolf Galland reportedly studied the summary himself, shaking his head in disbelief. The Germans had always assumed that superiority in design equaled superiority in war. They believed the craftsmanship of their Messerschmitts and Focke-Wulfs could overcome anything. But what they now faced was a different kind of strength altogether. A strength born from scale. The R-2800 wasn't just an engine, it was an industrial miracle. One that could be reproduced in thousands of identical copies, each as flawless as the last. In the mid-war years, Germany's engineering excellence had been a point of national pride. Every aircraft engine, from the Daimler-Benz DB605 to the Junkers Jumo 213, was hand-assembled by master craftsmen. But this very pride had become a weakness. The Luftwaffe's engines were delicate, high maintenance, and limited by scarce materials. The Americans, in contrast, had mastered the art of industrial repeatability. Every P-47 Thunderbolt rolling off a production line in Evansville or Farmingdale carried the same powerful heart, the R-2800 Double Wasp, ready to fly the moment it was bolted in. For the Germans, this was demoralizing. While their own aircraft mechanics spent hours fine-tuning engines before flight, American ground crews could replace an entire engine in the field within hours. If a Thunderbolt was damaged, it wasn't mourned. It was replaced. The United States had turned aircraft maintenance into a logistical rhythm, a wartime symphony of efficiency that no Axis power could match, and the industrial scale behind that system was staggering. American factories were producing over 500 R-2800 engines every month by 1944. Each one required precision tooling, advanced metallurgy, and vast supplies of high-quality aluminum and nickel. Germany, by that stage, couldn't even maintain consistent fuel quality. Allied bombers had crippled their synthetic oil plants, and shortages forced engineers to downgrade fuel octane ratings, robbing engines of power and reliability. The Luftwaffe engineers who examined the R-2800 began to realize they were fighting an enemy who could outbuild them 10-1, and do it with better quality. Every Thunderbolt engine they destroyed in combat was instantly replaced by another rolling off a production line, half a world away. Even more humiliating was the revelation that America didn't just build power, they optimized it. The Thunderbolt's turbo-supercharger system, built by General Electric, allowed the aircraft to maintain full power at 30,000 feet. That meant it could escort bombers deep into German airspace while the Luftwaffe's interceptors gasped for air. The Germans had experimented with similar devices, but their production limits and lack of high-temperature alloys made mass deployment impossible. By late 1944, the Luftwaffe's once mighty squadrons were flying fewer sorties than ever. Fuel was rationed, spare parts were scarce, and engines failed faster than they could be repaired. The engineers' analysis of the R-2800 became a symbol of what Germany had lost: not ingenuity, but sustainability. One Luftwaffe colonel summed it up bitterly. "We are fighting with diamonds, and they are fighting with steel, but they have mountains of it." That truth cut deep. The Americans had industrialized victory itself. Every bolt, every gear, every spark plug in that Thunderbolt's engine represented the collective effort of a nation that had mobilized its entire economy for war. Germany's engineers had been the best in the world, but they were trapped in a collapsing system. Designing masterpieces their factories could no longer produce. The R-2800 proved that wars are not only won by brilliance, but by the relentless force of production behind it. A lesson the Luftwaffe learned too late, staring at a captured engine that symbolized the unstoppable machinery of American power. By the time the Germans finished dissecting the P-47 Thunderbolt's power plant, the full extent of its impact was already being felt over the skies of Europe. To Luftwaffe pilots, the roar of that 2,000 horsepower R-2800 engine meant one thing: trouble. The Thunderbolt was unlike anything they had faced before. It was huge, heavy, and unrefined by traditional fighter standards, yet it ruled the upper altitudes with an authority that terrified even the most seasoned aces. In the spring of 1944, as the Allies intensified their daylight bombing campaigns, formations of P-47s became the iron shield of the sky. While the flying fortresses and liberators plowed through flak and fighters toward German cities, the Thunderbolts hunted ahead, diving through clouds with the fury of a thunderstorm. Hence their name. And at the center of this dominance was that monstrous Pratt Whitney R-2800 double wasp. Its brute power allowed the P-47 to climb faster, dive steeper, and survive longer than nearly any Luftwaffe fighter could dream of. German pilots were stunned by its performance. They reported shooting Thunderbolts to pieces, only to watch them keep flying, sometimes even returning fire. The R-2800 could take hits to multiple cylinders and still produce enough thrust to get a crippled plane home. Luftwaffe aces like Geo Nenther Rahl and Johannes Steinhoff remarked bitterly that American engines seemed to have a will of their own, surviving abuse that would destroy any German design. The Thunderbolt's turbo, supercharged engine gave it a decisive edge at altitude. Above 25,000 feet, most German fighters lost significant power, their engines starving for oxygen. But the R-2800, with its advanced turbo system, delivered full power even above 30,000 feet. This allowed P-47s to escort bombers deep into German airspace, territory once considered safe for the Luftwaffe. The psychological blow was immense. The Germans, who once dictated the terms of aerial engagement, now found themselves reacting, struggling, retreating. And the P-47's brute size, powered by its mighty engine, gave it another advantage: diving speed. When under attack, Thunderbolt pilots could simply point their noses downward and vanish into the clouds at over 500 miles per hour. No German aircraft could safely follow them at such velocity. The R-2800's rugged air-cooled cylinders absorbed the stress, while liquid-cooled German engines risked catastrophic failure. In combat reports, Luftwaffe pilots began referring to the Thunderbolt as the brick that could fly, a machine that defied both physics and logic. Behind every victory, though, was industrial might. The engine that powered the P-47 wasn't rare, it was one of thousands. While Germany's advanced designs like the Me-262 jet or the Tu-152 were few and fragile, the Allies fielded waves of Thunderbolts, each with an engine that could be built, maintained, and replaced effortlessly. The R-2800 didn't just make the P-47 a better fighter. It made the entire Allied air strategy sustainable. From D-Day onward, the Thunderbolt became the hammer of the Western Front. It strafed trains, tanks, and convoys, its roaring engine echoing through the French countryside like the sound of industrial vengeance. German ground troops came to dread that distinctive roar, the deep, mechanical growl that signaled death from above. By late 1944, Luftwaffe intelligence knew the truth: the R-2800 had reshaped air superiority. No amount of tactical brilliance or pilot skill could offset the overwhelming industrial and mechanical advantage it represented. The Americans had built an engine so reliable, so adaptable, that it powered multiple aircraft: the P-47, the F-6F Hellcat, the F-4U Corsair, each dominating its own battlefield. The Germans, who had once prided themselves on engineering mastery, were forced to watch as Allied skies filled with machines they could neither match nor outlast. The roar of the R-2800 was more than a sound of power. It was the sound of inevitability, the mechanical heartbeat of an empire that would not be stopped. As the war drew to a close and the ruins of the Reich lay silent beneath Allied bombers, a few surviving German engineers gathered around their notes, sketches, and fragments of the captured R-2800 engine. The testing hangars at Rechlin were empty now, the tools scattered, the machines abandoned. What had once been a proud center of aviation innovation was now a monument to exhaustion. Yet even amid defeat, one truth remained undeniable: The Pratt Whitney R-2800 had changed everything. It wasn't just an engine, it was a message. A declaration of what industrial warfare had become in the 20th century. The Germans had entered the war believing precision and intellect would decide victory. The Americans proved that power, industrial, logistical, and mechanical, was the ultimate weapon. The R-2800 was the beating heart of that revelation. In 1945, captured German reports on the Thunderbolt engine reached Allied intelligence teams. The tone was a mix of admiration and despair. One report read, "The Americans have achieved a synthesis of power and durability that exceeds our technical and material reach. The double wasp is not an engine to be copied. It is a philosophy to be studied." That sentence summed up the paradox that haunted every surviving Luftwaffe engineer. They had witnessed a machine born not from artisanal skill, but from industrial confidence. A confidence only possible in a nation untouched by the bombs it dropped. The R-2800 went on to power not only the P-47 Thunderbolt, but also the F-4U Corsair that dominated the Pacific skies, and the Grumman Hellcat that broke the back of Japanese naval aviation. Decades later, it would be remembered as one of the most successful piston engines ever built. An engineering marvel that defined Allied air power. Its influence didn't stop with propellers. The lessons it taught, about cooling, material science, and modular construction, would quietly shape the early jet age. When America began designing its first turbojets, the legacy of the R-2800's robustness carried forward. It had proven that engines didn't just need to perform, they needed to survive, to endure, to keep fighting long after logic said they should fail. For the Germans, the captured P-47 and its impossible engine became a symbol of the new kind of war they had underestimated. They had fought with precision tools. The Allies had fought with factories. The Americans didn't just build machines. They built systems capable of endless replication. And in that replication lay their invincibility. When historians later studied the reports from Rechlin, they found traces of awe among the despair. One anonymous engineer had scribbled a final note in the margin of a document dated April 1945. "This is what defeat sounds like. 2,000 horses roaring together, never tiring." That line, scrawled in fading ink, captured the quiet realization that the war in the air had been decided not by aces, but by engineers, and by a nation that could forge steel into strategy. After the surrender, many of those same German engineers would go on to work for Allied and American aerospace firms under Operation Paperclip. When they saw the jet engines of the 1950s roaring to life in factories across the United States, they recognized the same philosophy that had beaten them in 1944. Power, mass production, and reliability, the trinity of American dominance. And so, the legacy of the R-2800 lived on, not just in museums or blueprints, but in the very DNA of modern aviation. It was more than metal, more than horsepower. It was the mechanical proof of a truth that had shattered empires, that no matter how brilliant the design, it is the nation that can build and sustain that brilliance which ultimately rules the skies.